If you are new to the channel, then subscribe the channel and press the bell icon for further notification.
Okay student, welcome you all to this new lecture in basic level where we are starting definite integral. So in this lecture we will see from where this definite integral starts and what was the needs for this definite integral, what is Riemann sum and what is the actual definition of definite integral. Okay, then let's see this. Okay, so if we start definite integral basic, so let's start with an example, simple example. Let's see from that where we reach. Suppose we take a velocity of the particle, physics, start with little physics. Suppose a velocity of the particle, that is v0, is given. Velocity, you forget about this, velocity is equal to 5 meter per second, that is per second it is covering 5 meter. And we know in physics also you have seen velocity is nothing but change of speed with respect to, change of distance with respect to time. That is velocity, means in 1 second it is changing a distance of, it is covering a distance of 5 meter. So ds by dt doesn't, it just simply means that differentiation of s with respect to t, which means change in s with respect to time. What is the, you have seen the meaning of differentiation, change in y with respect to x. So here change in displacement or distance with respect to time. So change in distance by time is velocity. So that's why it is ds by dt. Suppose it is given 5 meter per second, and now you are asked to find the distance traveled by the particle between third and the fifth second. So it is running once t equal to 1, t equal to 2, t equal to 3, and then t equal to 4, t equal to 5, t equal to 60. So two instances they have taken at third second and fifth second. Between these 2 seconds, between this second, fifth and third second, how much time is there? 2 second time. So during this 2 second, how much distance it covered? So it is easy. It is covering 5 meter per second. So in 2 seconds it will cover 5 into 2, that is 10 meter. So from here to here, so it is actually curve. The curve is between v and t, not distance. Okay, the differentiation of distance, that is v. So that and t, this curve is given. So you can think that it is something of this fashion, 5 into 5 minus 3, that is 2. So if you think distance is 5 into 2, if you see this rectangle, what is the area of the rectangle? Length into breadth. So what is this length into breadth? If you take this is 5 and this is 2, whichever way you take, whether you see in this way or this way, that depends. So it is actually 5 into 2. If you take this is length, this is breadth. If you take this is length, then this is breadth. So it is actually length into breadth. That means actually area, what you are calculating by calculating distance as, you are calculating the area under this curve velocity during these two intervals. So that is area under this curve you are calculating. So that is clear. So that means we need to find, in some cases, in some physical problems, we need to find the area under that curve. One example is this one. Here, to find distance, we need to find this area. If I note this area, then that is the distance. Now this curve cannot be straight. If it is a straight curve, then every time you can find using length into breadth area, there is no need. But you can have some area which are not your standard format, that is not rectangular, square, trapezium, of this format. Suppose your graph is of this fashion. Suppose your velocity is equal to t square in the format, that is y equal to x square format. Now you need to find that distance traveled between A to B. Not this one, this is not the distance level, this is actually curve of the velocity. This is not distance. You don't think that distance is here at t equal to 2, it is at here, it is no. It is actually the velocity is changing. Here it was fixed. Every time it was, at this time also velocity is 5, at this time also velocity. But here, if you, as you are increasing your time, your speed is also increasing. So that's why it is a parabolic shape, y equal to x square. Now to find this area, how to find this area? So the idea is you can split it in small segments. You make it as very small rectangles and then you add all these rectangles. That will be equal to that area. So the more rectangle you take, the more smaller rectangle you take, that is smaller width, and the number of rectangles is higher and higher, and more lesser width. If your number is increasing, that your width will be decreasing. So if you take very close rectangles, that means more and more number of rectangles, then your area will be more and more accurate to its original area. So let's divide this portion into n intervals, that means n rectangles. So length of each interval will be equal to b minus a. This position is b, this position is a. So b minus a divided by n. Now for more accuracy, that we have understood, we will increase this n, and this is equal to h actually. We will increase this n to infinite. So we will be taking lots of rectangles. Because you are taking infinite number of rectangles, so each rectangle width will be very close to 0. You can say it is, for more accuracy, your n will tend to infinity. If n tends to infinity, then means your h will tends to 0. This width is very, very small. So that you can take more and more number of rectangles. So now the total area, if I take of this sum of this all the area of these rectangles. So each rectangle is having all of them. If you take the first rectangle, the width is h and the length this one. What is the length this one? This is a. So this height is fa. This height is fa plus h, because this point is a plus h. This point is a plus 2h. So this height is a plus 2h. Similarly, the last one will be equal to a plus n minus 1 into h. Because if you see, if you divide it into 1, 2, 3, suppose in 3 segments from here to here, so what is this one? This is a plus 2h, a 2 it is. So if you're dividing in the n segments, so this one will be n minus 1 into h, because actually you are starting with 0. That's why. So the first one will be the length of area of this one will be, this is h and this height is f of a, and here again the width is h, the height is here f of a plus. So you are getting this area, again you are getting this area. So finally this area will be equal to h into f of n minus 1 into h. If you take h common, then this is of this fashion. Now this series you can use this summation symbol. We have seen this one, because this is summation of this one. It starts from r equal to 0 because no r is there. Final r is here n minus 1. So a plus r h. So r starts from 0. If you put 1 by 1 r value, this series will come. And this, it is in terms of h. If you write in terms of h, then this is the formula for this sum. And if you write in terms of n, this is the formula. You replace this h in terms of n, that is b minus. If you write n in terms of infinity, then every variable should be n. So here I have not changed it, you change it. It will be b minus a by n. Now this is one way. There can be another way. Some people can do it in different ways. So some people can say, sir, I will divide from this side. Means actually what I will do, I will take this, instead of taking this rectangle, I will take this rectangle, the upper one. Here earlier one I have taken, you see this one now. The idea was of this fashion. So suppose this is your point. So someone is in, this is your h. H is very small, but I have to see it. So in the first case I have taken this area. Some people can say, sir, I will take this area. That also can be done. So here what he will do, he will take all these areas. So this area will be obviously more than this area. If the curve is of this fashion. If the curve is reversed, then it is different. If you see this curve, it is continuously increasing function. Then this method will give you more area, this method will give you less area. But if your curve is of this fashion, then the method 1 will give you more area, method 2 will give you, here it was method 2, method 1. Method 1 is whatever you are getting FA, you continue with that one. Whatever you are getting FA, you continue with this one. So method 1 will be more than method 2 if it is a decreasing function. And decreasing function means you will start from this side, the second one. This is method 2. So it depends whether it is increase or decrease. Similarly, so that you can say which one will be more, which one will be less. So someone can start from this. So if it is starting from this, then what will be its formula? It will start from r equal to 1, because the first one will be, you are taking this height and this is h, and you are taking this is as a height, because you are taking this is as a rectangle. So this height is f of a plus h, and this is only f of a, this height is f of a plus h. So it will start from r equal to 1 and it will go to n, because last one you will be counting this height. So it will be f of a plus nh, the last one. That is fb actually. If you put h is equal to b minus a by n, so n will get cancelled, a will get cancelled, it will be fb, because this height is fb. So in that case your formula will stand like this. R starting from 1 to n, it was r starting from 0 to n minus 1. So from here you can see whether it is method 1 or method 2. So you have to be clear one. So in this case, from both this graphical method, in this case only, in this increasing function, for the increasing function case, the method 1 will be less than the required area, then this one will be more than the required area, because required area is under this curve. Here you are leaving some areas, even if you take n number of, infinite number of rectangles, but still you are left with some areas. So you can say this is somehow less than the original area, and this is somehow more than the original required area, but it is very close. So that's why it is written. So the required area will be in between these two graphical methods. So the sum for the calculating this area, this sum, what you are doing using this sum, that is known as Riemann sum, and it is symbolically written as Rn. If you introduce that limit n tends to infinity before it, Rn is this much, this summation, b minus a by n r equal to 0 to n minus 1 f of r plus h. You can use this one also, but generally we use this one. So if you introduce a limit n tends to infinity before that, that becomes the definition of definite integral. So what is the definition of definite integral fx over a to b is this one. N tends to infinity, this is the definition of definite integral. And it is denoted by this symbol. So this entire thing is denoted by this small symbol. So this symbol means a to b, integration a to b and then dx. The entire symbol fx is over the function. That is known as, original thing inside this one is this one. So this is just a symbol. So we'll see what does this symbol represents. So we write this is equal to this. Okay. In particular, suppose your a is equal to 0, b equal to 1. If you put a particular case a b1 a0 f of x dx, so if you put it there, L tends to infinity, a0 b1, so it will be 1 by n, r0 to 1, and if you put a0 b1, what is h? B minus a by n, so 1 minus 0, so it will be 1 by n, so it will be a0, so it will be r, instead of h it is 1 by n, r by n. So you recall in one of the limit questions I have used this one, I told you I will explain it in definite integral. So you can recall this one. Actually summation symbol changed to how to come from this to this side. So this simplification I have, shortcut methods I have applied. So if there is a summation sign, you convert it to integration. If whatever r by n you put it x, instead of r by n it is x, and instead of 1 by n it is dx. So you have to be careful. There should be summation, there should be 1 by n, and you have to represent it in r by n format. So then you can replace this limit problem into a simple integration problem, definite integral.
If you like the video, then press the like button and please give your valuable comments in the comment section.